So although there are natural ways to get changes in climate, there are also man-made ways. We believe that man is changing the climate. And probably of most notoriety is as we burn fossil fuels, we put carbon dioxide into the Earth's atmosphere that wasn't there before. So for instance, what this first graph is showing you is how do we get our energy as of 2007 anyway. Notice that the three largest sectors are burning fossil fuels, creating carbon dioxide. This over here is showing you the rise in carbon dioxide concentration, and actually can you kind of see the Industrial Revolution there, about 1800, and the amount of carbon dioxide in the Earth's atmosphere took off. So we are putting extra carbon dioxide into the Earth's atmosphere. And carbon dioxide, remember, is one of those greenhouse gases. And what a greenhouse gas is something that basically traps heat. Okay, so that's why we generally have a global warming effect going on here. So annually, what are we doing with regard to putting carbon dioxide into the atmosphere? Well, annually, we're putting about 1,000 pounds of carbon dioxide into the air because we fly. This is just the United States. Annually, we're putting about almost 9,000 pounds of carbon dioxide because we drive. Annually, we're adding about 1,000 pounds of carbon dioxide because of our trash. We are adding about, again, almost 9,000 pounds of carbon dioxide as we heat and cool our houses. And we're adding about 17,000 pounds of carbon dioxide because we need to, because of our use of electricity. So this is looking at surface temperatures from 1880 to 2000. Okay, notice this has been known as, I think, kind of like the hockey stick diagram. Okay, so notice the temperatures are increasing, and this is showing you the way the white is neutral, means that it is basically no change between 1951 to 1980. Over here it means it's gotten warmer. Over here it means it's gotten cooler. So you can kind of see how temperatures have changed worldwide. It's kind of a cool picture. This is showing you, again, kind of up here means temperature is getting warmer. Down here means temperature is generally cooler. So you can kind of see the trend in surface temperatures. And like the slide says, it's most likely that kind of this most recent change in surface temperatures is due, it correlates, what we say, or tracks really well with the increase in amount of carbon dioxide in the Earth's atmosphere. So carbon dioxide is a greenhouse gas, but there's other greenhouse gases. Methane, and we get methane from, as you can see, just mining the coal. We get methane from rice production, from raising cattle. Now these sort of activities, especially rice production and raising cattle, I mean, those were in existence before the Industrial Revolution. So, but they're associated with populations. So we increase methane. That's another way to get global warming. Notice just even our use of fertilizer. We put more nitrous oxide into the atmosphere. That is another greenhouse gas. CFCs, in addition to destroying our ozone, are another greenhouse gas. So I'm going to kind of remind you of this idea of positive feedback versus negative feedback. And it doesn't mean that something positive is happening in positive feedback and something negative is happening in a negative feedback. What it means is, in a positive feedback, it means whatever you started with, like situation A, something else happens, we'll call that change B, and whatever B is, it enhances A to happen. So it encourages A to happen. So it's a positive feedback mechanism. It doesn't mean it's good. Negative feedback mechanism means that your change A results in a change B, and that second change will kind of fight or diminish A. So basically, a negative feedback mechanism is going to kind of die down, and a positive feedback mechanism is going to maybe like build up. So if we look at global warming in terms of a positive feedback mechanism, again, is global warming positive? No, but it can kind of feed on itself. So for instance, if we tend to have warmer oceans, okay, one of the things that will do is it will we'll have more melting. And if we have more melting, that means we're going to have less ice cover. And if we have less ice cover, then that means that ice was more reflective than dirt, or ground. Something nice green grass is going to absorb energy versus something ice covered or snow covered is going to reflect it. So we've got reduced reflectivity, which means more absorption, which means that we're going to have warmer surface temperatures. Our oceans are going to tend to be warmer. So do you see how this is what we call a positive feedback mechanism? So this kind of feeds on itself and kind of takes on a life of its own and tends to enhance global warming. But now here's an example where global warming should kind of peter down. Global warming should shut itself down according to this kind of negative feedback mechanism. Here's how it would go, and I think I might have shown you this before. For instance, let's just say our surface temperatures are increasing, global warming. Well, if that's the case, then we know that we're going to get more of just picture the large bodies of water, the oceans, we're going to have more evaporation. And if that's the case, that water will eventually condense in the form of clouds in the atmosphere, and we'll have more cloud cover. Now, one of the things we know about cloud cover is it blocks incoming solar radiation. So we would tend to, because of blocking the incoming solar radiation, we would tend to ultimately have global cooling if this were the case. So see how that's a negative feedback? Kind of broke the cycle of global warming. Well, aerosols can have a cooling effect too. Now, I think these last few slides are just showing you how complicated it is. What aerosols are suspended liquids or particles in the Earth's atmosphere. And if we kind of think of aerosols as being, in this case, man-made. So for instance, I'm going to show you a picture here where we literally see kind of the pollution in the form of aerosols coming from, I think it's Taiwan. But aerosols also block incoming radiation, just like clouds do. And so aerosols, the presence of aerosols, would generally have a cooling effect. But so aerosols in this case are a pollutant, right? But if that blocking incoming radiation kind of adding a cooling effect, like this says, you can't hang your hat on it. And in general, the cooling effect from the presence of aerosols does not combat the warming effect from the presence of greenhouse gases like carbon dioxide. So yeah, China. Let's see, there's China, there's Taiwan, and kind of shown on, can you kind of see this haze right here? This would be like aerosols. It's not a cloud, it's like haze. And so again, this would block some incoming solar radiation, kind of have a cooling effect. But not enough to counteract the other thing we're doing to the atmosphere.